So in the previous video, we have talked about the theoretical aspect of cubes and squares. So now's the time to actually use it. This is video 2 of the chapter, that is squares and cubes. We are going to take almost around 13 to 15 real questions straight from your textbook, that is NCERT, and solve it using the tricks and nothing else. If you have not watched the previous video, please pause this one and go watch that video. Because in this particular video, we are just going to solve the questions. I'm not going to reiterate the theoretical aspect. We are just going to apply the formulas and the tricks that we have learned in the previous video. So let's start. So these were the things that we discussed in the previous video. The first one was any number which ends with 2, 3, 7, and 8 are not perfect square. That is the first thing that we need to remember. The second thing, sum of the first n odd numbers. So 1 plus 3 plus 5 and so on. If I'm adding, let's say 10 numbers, 1 plus 3 plus 5 plus 9 and so on. So it is going to give me a 10 square, which is equal to 100. If I'm going to add the first three, 1 plus 3 plus 5, this is going to give me a square of 3. Okay. The next one, so we have discussed these two. Then n plus 1 whole square is equal to n square plus 2n plus 1. This will help us in finding the squares of the numbers for which the preceding square is already known. So for example, if I already know what is the square of 25, this is 625. Now I can calculate the square of 26, which is equal to 25 square plus 2 times 25, that is 50 plus 1. I just have to do the addition of these. Then if I want to find out the squares of the square root of a number, then prime factorization can help me a lot in that, right? We have discussed it in the previous video. After that, we talked about cubes also, in which if I want to find out what is the cube root of a number, I'll first calculate the prime factorization of that number. For example, if I'm trying to calculate the square root of a number, I'll do the prime factorization, let's say a to the power b into c to the power d. This is the prime factorization of a number. If I want to calculate the square root of this number, I'll divide the powers by 2. If I'm trying to calculate the cube root of a number, I'll divide the powers by 3 and simply I'll get the square root and the cube root of that particular number. So let's start with the questions part. So first of all, I've taken almost around 8 questions from your NCERT for square numbers. Let's start with the first one. Which of the following is not a perfect square? So do we remember what are the numbers which cannot, so a number which ending with a 2, 3, 7, 8, do we remember that thing? So a number which is ending with a 2, a number which is ending with a 8, a number which is ending with a 7, they cannot be perfect squares. Do you remember, do we remember that? So these three cannot be the perfect squares. A number ending with a 9 can be a perfect square. It should, the square root should be ending with a 7 or something. So let's see. This cannot be a perfect square since it is ending with a 2, cannot be a perfect square ending with a 8, cannot be a perfect square ending with a 7. This can be a perfect square which is ending with a 9. So obviously the last digit can be 7 or the last digit can be 3. Now, how do I identify? If I want to solve this question further, how do I identify what is the square root of this number? So basically, I can do the prime factorization, I can do the approximation approach. So let's go ahead with the prime factorization, let's say. So 1089, this is a this is a multiple of 3, 3, 3, 9, 6, 18, 3, 9. Then again 3, 1, 2, 1. 1, 2, 1 is a multiple of 11. 11 into 11 and 11 into 1. So this is basically 3 square and 11 square. If I do the square root of this number, I divide the powers by 2. So it will become 3 to the power 1 into 11 to the power 1, which is nothing but 33. So 33 is going to be the square root of this number. So this is the only out of the 4 given which is a perfect square. Okay, you can do it with the approximation part also, in which you already know that 10 square or not 10 square, 10 square is 100. Let's say 30 square is 900. With the help of n plus 1 whole square is equal to n square plus 2n plus 1, you can calculate 31 square also, which is equal to 30 square added with twice of 31, that is 62 plus 1, so 963, right? This is something. Apart from that, sorry, minus 1, so 961. Apart from that, you already know what is the square of 35. So 1225. So it has to be below this number, because 1225 and 1089. 1089 is below the number. Okay, below the number 1225. Perfect. So you can do the approximation. You can find out for 31, 32, 33, 34, and so on. Obviously, you know, if it is between 30 and 35, the number should end with a 3, because the square is ending with a 9. So the original number should either end with a 3 or a 7. So it cannot end with a 7, because the number is below 35 and above 30. So it should be a square of 33. You do the manual calculation and you'll be able to find out. Let's move on to the next question. Which of 64 square, 108 square, 292 square, and 36 square has last digit as 4? For the last digit calculation, you just see the last digit of the original number. So if I take 64 square, so I'll just look at 4 square. 4 into 4, 16. So the last digit is 6. 108 square. 8 into 8 is 64. 4. So the last digit is 4. 292 square. I'll just focus on this unit digit or the last digit. 2 square is 4. And finally 36 square. 6 into 6, 36. So the last digit is 6. So out of these 4, there are only two numbers which has the last digit as 4, that is 108 square and 292 square. This is what is written in here. So 108 square and 292 square are the correct answers. Moving on to the next question, given that 125 square is 15625, what is 126 square? Now remember the formula, n plus 1 square is equal to n square plus 2n plus 1. This is the formula that we have discussed in the first part of the video. So 126 square is equal to 125 square added with twice of 125 added with 1. So it will be equal to 125 square is already given to you, which is 15625, added with this, which is twice of 125, which is 250, added with 1. So 57815, 15875 is going to be the final correct answer. This is going to be your final answer. So 15625 added with 251, which is this, my bad. Okay, so this is going to be the final answer for this question. Moving on to the next one, find the side of a square whose area is 441. This is basically asking you to calculate the square root of 441. This is basically asking you to calculate the square root of 441. 441, square root of 441. Now, how do you calculate the square root of 441? You can either do the approximation or you can go for prime factorization. Let's do it both the ways. So if I do the approximation, 20 square is equal to 400. 2 square is 4 and 1 0 will produce 2 zeros because there is a square over it, right? Similarly, 25 square is equal to 625, which is a way higher number. Now, since the square is ending with a 1, the original number or the perfect square root should also end with a 1. So there's a good possibility that 21 square is equal to 441. I'll just do the calculation on the side. 21 and 42, 441, absolutely correct. So I can say that the side of the square is equal to 21. You could have done it with prime factorization also like this. So this is a multiple of 3. 3, 1, 3, 4, 12, 7, 21. Again a multiple of 3, 4, 12, 9, 27. Multiple of 7, 7, 7, 49. Multiple of 1. Right? So basically 441 is equal to 3 square into 7 square. If I want to take the square root on both the sides, so the powers will get divided by 2. So it will become 3 to the power 1 into 7 to the power 1. So again the answer is 21. Okay. Now moving on to the next question, which is smallest square number which is divisible by 4, 9 and 10. Now, in this question, a number which is divisible by. So there are two parts of this question. The first one is I need to find out the smallest square number, which is a square, and it should be divisible by 4, 9 and 10. So the numbers which are divisible by the given numbers, I have to take the LCM of the given numbers, right? So first of all, I'll go for the LCM of 4, 9 and 10. Let's take the LCM. 4, 9 and 10. 2, 2, 4, 9 as it is, 2, 5, 10. 2, 1, 2, 9 as it is, 2, 5, 10. I take 5, 1, 9 and 1 and 3, 1, 3, 1 and 1, 1, 1. So basically the LCM is 2 square into 3 square into 5 to the power 1. I want a square number, a perfect square. So what do I need to do? I basically, if the number is a perfect square, it means that the powers of each prime factor should be divisible by 2. This we have discussed in our previous questions and the previous video. The power should be divisible by 2. This is a power which is divisible by 2. This is allowed. This is a power which is divisible by 2. This is allowed. But this is not divisible by 2. So what I need to do to make it the smallest square number? Can I say if I multiply 5 to it, I'll be able to transform this number in this particular format. Now it is allowed. Now it is a perfect square because all the powers of the prime factors are divisible by 2. So basically, this is the number that they are talking about. This is nothing but equal to 900. Okay, so this is something that is going to be very important because a lot of students struggle with these type of questions. So first of all, try to understand that there are two parts of this question. The first part is you have to find out a number which is divisible by 4, 9 and 10. So you have taken the LCM of 4, 9 and 10, right? The number came out to be this. Now I have to make it a perfect square, the smallest perfect square. Now this power is divisible by 2, this power is divisible by 2, but 1 is not divisible by 2. I made it 2 by multiplying another 5 to the power 1 to it. So now this number became a perfect square, which is 900. Move on to cube numbers. So first question, find the cube roots of 27,001, 10,648. Take the approach of, in this particular question, 27,000 cube root. Okay, remember this thing that when we talked about squares, the number of zeros in the original number becomes twice when you are squaring it. Similarly, the number of zeros will become 3 times when you are cubing it, right? When you are raising it to a power of 3. So similarly, can I separate this number into two parts? 27 and 3 cubes. Since I'm now calculating the cube root, these 3 zeros will get reduced to 1 0 because I'm reversing the order. When I'm cubing it, when I'm raising it to a power of 3, it will become 3 times. But when I'm doing the reverse order, the number will get divided by 3, right? So 3 will become 1. Similarly, what is the cube root of 27? 3 into 3 into 3 is 27. So cube root of 27 is 3. So this is equal to 30. You could have done this question using prime factorization also. That is also fine. Similarly, 10648. I do the prime factorization. 2, 5, 10, 3, 6, 2, 4, 4, 8. 2, 2, 4, 2, 6, 12, 6, 2, 1, 3, 3, 1. This is a multiple of 11. 11, 1, 11. 2, 22, 1. 11, 11. And 11, 1. So this 10648 is equal to 2 cube into 11 cube. If I have to do the cube root, the powers will get divided by 3. So it will become 2 to the power 1 into 11 to the power 1, which is equal to 22. That is going to be my final answer. Okay. Second question, what number multiplies 1323 to make it a perfect cube? Like the question that we have done in perfect square. So again, do the prime factorization. 1323 divisible by 3, 3, 4, 12, 4, 12, 1. Divisible by 3, 3, 1, 3, 4, 12, 7, 21. Divisible by 3, 4, 12, 3, 9, 27. Divisible by 7, 7, 49, 7, 1. So 1323 is equal to 3 cube into 7 to the power 2. Now, if a number has to be a perfect cube, the power should be divisible by 3. Like we have discussed this thing in squares. If a number is a perfect square, the power should be divisible by 2. If a number is a perfect cube, the number should be divisible by 3. This is divisible by 3, it will work. This is not divisible by 3. 2 is not divisible by 3, so I have to make it 3 so that it is divisible by 3. I'll multiply a 7 to the power 1 so that both 7 into 7 into 7 will become 7 to the power 3. So that's why what number should be multiplied? It should be 7. Perfect. Moving to the next question, which is a true and false. The cube of any odd number is even. No, odd cube is odd itself. So it is a wrong statement. There is no perfect cube that ends with an 8. We have already discussed this thing that a perfect cube can end with any digit. Any digit. The cube of a 2-digit number may be a 3-digit number. The cube of a 2-digit number may be a 3-digit number. Okay. It is also not possible because even the smallest 2-digit number, let's say the smallest 2-digit number is 10. If I cube it, it is a 3-digit number, 4-digit number, right? So a cube of a 2-digit number can never be a 3-digit number. It has to be at least a 4-digit number. So this is again false. Cube of a 2-digit number may have 7 plus digits. No, it is also not possible because 99 cube is a 6-digit number, right? And if I talk about 100 cube, it is 1, 2, 3, 4, 5, 6. How many digits? 7 digits, right? So 99 cube, which is the highest 2-digit number, is a 6-digit number. 7 digits are not possible. So this is also incorrect. And finally, cube numbers have an odd number of factors. That is not always true. Odd number of factors, it is not compulsory. So all of these statements are false. Now, moving on to the next question. Guess the cube roots of these. So again, you will not do factorization. It is given in the question. You can simply do the guesswork or the approximation. So this number, the original number should end with a 1, right? If I talk about 1331, this is basically just think about 10 cube. It is nothing but 1000. Very close to this number, right? So it can be a 11 cube. You just check it. It is going to be the correct one. Similarly, 4931. If I let's say talk about 20 cube, this is equal to 8000. 10 cube is 1000. So this number should be in between 10 cube to 20 cube. Now look at the unit digit. So 1. So just think about the unit digits of the original number, which when cubed will give a unit digit of 1. So 0 will give 0, 1 will give 1. So 1 is possible. 2 will give 8, 3 will give 7, 4 will give 4. We have discussed this thing. 4 into 4, 16 into 4, 64. So it will give 4. 5 will give 5, 6 will give 6, 7 will give 3, 8 will give 8, 8, 64, 2, 9 will give 9, 9, 81, 9. So this is something. Okay, I've written the question incorrectly. It is 3. So just again do the entire thing. 7 is a possibility. So I think 17 we can check, 17 cube. Same goes for 12167 and 32768. So it is going to give the same thing. So we have discussed for these two. Same goes for 12167. It should be in between 20 to 30 and 32768 should be in between 30 to 40. Okay. Next one, which is the greatest? So 67 cube minus 66 cube, 43 cube minus 42 cube, 67 square minus 66 square. So obviously this is going to be greater than this. Okay, and this is going to be greater than this. So I can simply say that which is the greatest number. Always remember this thing when let's say I talk about the same number, 67 cube minus 66 cube. 43 cube minus 42 cube, right? Higher the number is going to give higher difference. Always remember this thing. So the first one is going to be greater than the second one. If all the other things are same, it means that the difference of one is same, right? These are consecutive cubes ka difference. So the first one is greater than the second one, and obviously cubes ka difference is always greater than the squares ka difference if the difference in the number is just 1 or 2 or anything. Okay, the difference in the number should be consistent. So that's why 67 cube minus 66 cube should be the final answer. This is something that I wanted to discuss. So we have discussed the Ramanujan's taxi cab number, which was 1729, right? If you remember, it can be broken into two parts, 9 cube plus 10 cube, right? Or 1 cube plus 12 cube. There are more such numbers. This was the smallest one. There are more such numbers like 4104 and 13832. They are also be able to broken up into a similar fashion, but 1729 is the smallest one. Okay. I think this is something that I wanted to discuss, and that's the 13 questions, and we didn't use anything apart from the tricks and the theoretical aspect that we discussed in our previous session, that is video 1. So this is basically the true test of the understanding from our previous session. Okay. So I think that's all for the video. Uh, Please wait for the next one, and we'll cover the entire all the chapters which are there in your textbook. See you guys then. Bye bye.